Hey guys, this is SolidWorks Group. Today we're gonna have a look at how to create the sheet metal part. So we're gonna actually divide it into several kind of tutorial video because actually there are so many different levels of understanding of sheet metal. Since sheet metal is actually one of my biggest strengths, and then this is just what exactly I'm working on in my industry. So just let's make it short for the description and let's just get into it. Like, and then I will explain one by one. Alright, so let's just start with the part first, and then let's just create a sheet metal, just any kind of part for now. But before we going through like any kind of design process, I mean, for the sheet metal part, it could be like really various kind of structure that you can create it. But but like I think at least actually you have to know some kind of basic understanding of actually what kind of feature we have, and also how we can actually manipulate the parts. I think those are the things that we have to know. So alright, so let's dive into it. So firstly, I just want you to just set any kind of unit of measurement, but for today I'm just gonna set as IPS first. And then so the way of actually starting sheet metal is it's just pretty much same as extruding, but if you go to the feature, the way actually you're just creating a feature for extruded part is just basically once you just create one center rectangle. So I'm just gonna do 2x2, and I'm just gonna go to extrude pose, and then just 2-inch. Yeah, this is just like one way of actually just creating a the cube. But if you go back to like this, just like rectangle. If you go to the sheet metal, if you didn't activate this tab, and then I just want you to right click that tab and then just like go to tabs, and then you can just activate this sheet metal. Okay. If you go here, and then there's a lot of actually parts, or there's a lot of actually features are not activated. As already mentioned many times, whenever actually those features are grayed out, means this is not suitable, or just like this is not the case that you can just run those other things because there's no sheet metal created. So for you to activate those things, you have to basically first have some kind of sheet metal. Okay, so I just want you to click Base Flange. This is the most common way of actually starting with a flange. So you can just basically select this sketch, and then as you can see, this is just like creating on some type of sheet metal, kind of very thin sheet metal. So let's have a look at the left features. Okay, so there's a use material sheet metal parameter. If you click it, and then that's just gonna be basically it's just like saying there's no material kind of assigned, because actually we didn't assign any material yet. But it's just like there's two ways you can just like input some kind of gauges, because each sheet metal part there's a gauge you have to assign, and then which material you're gonna assign. So based on that specific sheet sizes of your industry, and then they're gonna actually just use specific kind of spec that you're gonna use for specific parts. So you have to first predetermine which type of gauge and then what kind of material, so then actually you can start designing from that point on. Okay, so for our case, instead of using just like the customized number, I'll probably just recommend you actually just like kind of set the gauge table. And then for another tutorial video, I'm just gonna go through how to set the gauge table for your company, or just like I think that'll be really beneficial for you to set up, so you don't necessarily go kind of random number, because like each person has different kind of gauge number kind of understanding. So some people can go like like 0.048, but some other people might go actually just 50. So that's going to be causing a discrepancy of actually just different thickness. And then when it comes to programming those sheet metal, and then programmers gonna understanding differently, so that's gonna cause such a huge issue. Okay, that's why we'd better just set a template or just table, so we can actually just start from there. Okay, so for our case, actually just like we already set some a couple of actually just table, and for the next video I will go through actually how to set the gauge table for your company. And then once you just like select one of them, and then you'll be able to see some of the options from the table. You can actually select from there. So there's a 10, 12, 16, 18, 20, 22, but it could be going even higher or lower, like 24 or even lower gauges. And just to let you know, I know actually 10 is lower number, and then 22 is just a higher number, so you might think 22 gauge is just kind of thicker material, but if I select the 22, as you can see, the thickness is just way thinner. But if you select the 10 gauge, you can see actually this is so much thicker. So you can just think like kind of in reverse way. So 10 gauge is higher gauge, so like it's thicker, but 22 gauge is way lower. And this thickness is really depends on what kind of material it is. So if you select a stainless steel, and then that's gonna show different thickness for different gauge. Okay, just keep that in mind. But for our practice, I'm just gonna set 18 gauge, which is just one of the most commonly used material for our case. And then yeah, so you can also just like change the direction of this extrusion. But for now, I'm just gonna leave it as what it is. And then there's some kind of like bend allowance, and then there's an auto lift. Those things are like not kind of for this case, because actually we don't have any bend and we don't have any kind of like corner point. So for example, let me show you what I'm talking about. Okay, so for now I'm just gonna create a base flange, just with the kind of this, the default value, and then all right. So firstly, as you can see, actually there's a lot of actually just like sheet metal kind of features activated, but I just want you to just understand the foundation of like some of the sheet metal scale. I just don't want you to actually have a look at some ham, meter flange, and then sketch band. Like, just don't care about it for now. Let's just focus on only two features, okay? The first one is base flange, and the second feature is edge flange. If you know only those two, you can actually just like handle most of the sheet metal work, because that could be handled like pretty much everything, okay? But for this case, instead of actually creating this kind of sketch, a little bit different sketch for this time, okay? So I'm just gonna delete it, and then what I'm gonna do is I'm gonna right plane click, and then I'm gonna actually just create some sketch like this, okay? And just like it's just random value, okay? And I'm just gonna select two line and then just make equal, and then I think this is not the best one. I'm just gonna select this one, just move a little bit, and then select this point, and then just mid plane. And yeah, I'm just gonna type 4, and then for this one, I'm just gonna type 1.5 inch, okay? And I'm just gonna exit sketch, and then just make a base flange. And then this is also one other way you can just like create kind of the specific thickness. So you have to make sure just not creating some closed loop. It's just basically open kind of lines. And then even though actually we didn't provide any kind of like corner point, like kind of fillet, it's just automatically recognize this is the corner point. So that's the point. Actually, just like it's just recognizing some kind of the specific just gauge with the specific band radius that we provided. It's gonna be auto assigned, so it's gonna be 0.0510. Okay, and then some other things such as the kind of K factor, and then some other actually things like auto lift. Those are definitely actually just another actually just big topic that I'm gonna actually just have a kind of go through with you. This is just more for the kind of engineering kind of calculation, so we can actually just like get the accurate sizes of kind of banding, because sheet metal part is just normally like band allowance, and then how accurate this size after banding based on our just calculation is just quite important to understand, especially if you're working on very high accuracy kind of sheet metal industry. But yeah, I will go through another video, because this is super important, and then this is also one another actually just like hours of actually just like discussion needs to be done. So yeah, I will actually just like go through next time. But for today's video, I'm just gonna have a look at actually what's the kind of the base flange. So from here, if you go to direction 1, and then it seems very familiar, right? So we can just go to mid plane. It's pretty much the same as just kind of extruding. So we can actually set the mid plane at 4 inches, just like in both direction. And then yeah, that's pretty much it. And then we can just click OK, and then that seems good. That's already almost like seems like a cover, like electric kind of cover. And then we can even actually just assign the galvanized steel, so make it even like look like more galvanized steel. And then we can just apply the rear view, and then this is just basically what this galvanized. And then one other topic that we want to have a look at is just basically edge flange. So what edge flange is, I know, so if we want to actually just make another flange over here, but if you're having a look at the sketch, 2D sketch, we were not able to just creating like 2 more flanges from just only one 2D view. So that's why we have a function of the edge flange. So if you click the edge flange, and it's just like prompting me to select the flange or edge area. So we can just select this edge, and then as you can see, even though I didn't click anything, it's just like kind of, if you go up, and then that flange is gonna go higher, and then if you go low, and it's gonna follow your mouse cursor, okay? And then I'm just gonna click any point, and it's just gonna stop, okay? And if you scroll down and there is a flange length, this is the point that you can actually just like, play and also just like, manipulate the length of it. And then there's another things which is just like the 3 different options, which is the outer virtual sharp, and then the second option is inner virtual sharp, and then the last one is basically the tangent bend. But normally actually just we use a lot of actually just like the outer virtual sharp, but if you click it, this is just a little bit extended, but actually it doesn't really matter whichever you like. But if you're having a look at this, so this point is normally actually just like kind of change from the flange position. So if you select this just kind of inner, basically material inside, this is just mostly kind of right at this point, right? But I'm just going to click OK for now. But as you can see, actually this auto lit or just like kind of corner point is just like automatically just creating. That is just because if you actually just like go to the edit sketch and then scroll down, and then there's some type of like there's a flange position and there's a trim side bands over here. That is just because actually if we didn't assign, I'm just gonna uncheck this one and then just click OK. And then that is what's gonna happen, and this is very unrealistic looking of this kind of band because it doesn't make sense. Almost zero thickness of this kind of gaps kind of creating it just doesn't really make sense. So that's why actually SolidWorks is just like automatically assign this the trim side band, so it could be also actually making more sense realistically when it comes to band. So that's just one good feature when it comes to doing some kind of material inside. But one other actually feature is the third one, which is just like outside. So basically it's gonna be actually just like considering some kind of band radius, and then it's gonna be going out as much as the band radius. So once you click it, and then you'll be able to see actually this corner point is pretty clean. However, actually as you can see, there's a lot more gaps between here. So this is the point that actually we have to just make a decision call that whether or not we're gonna do material inside and then just put some kind of corner, or we can actually just like close this corner by using another feature which is called closed corner. Okay, so where's the closed corner? So if you actually just go search menu, and then there's if you type closed, there's a closed corner, and if you click it, and then you'll be able to actually just like select 2 or just one face, it's going to be automatically recognizing 2 different kind of corner point, and then you can just manipulate. I want to actually just distribute kind of same amount, or you want to only extend the front one to just cover up, or just the last one is just vice versa. But for me, actually I personally want to do this way. So you have a look at it. Yeah, this one is actually seems actually a little bit unrealistic. Okay, let's just go for the first option basically. Yeah, I think this one is going to be much cleaner. Yeah, so this one is pretty tight, but the way we can actually just manipulating is just like we can actually just provide like more gaps, like 0.0. So I'll say 1/16. It's just too wide. So I'm just gonna do. Yeah, I think this one is actually pretty much good enough, and so you can also assign to this side as well. So by providing this kind of like little bit of gap, we can just cover up actually just this corner, so it doesn't have a lot of actually just gaps between, and also that's going to provide more rigidity. So that's why I just want you to actually have a look at 3 features. The first one is base flange, the second one is edge flange, and then once you know the edge flange, and then you'll be able to actually just create any kind of like edge flange, so you can even actually start from there and then just click OK, and I'm just gonna do one more time, and then you can also just create another feature over here and then click OK. And then this is perfect. It's so much easier. It's just keep connecting. You can also do whatever you want. But there's one of the important things that I want you to remember is, so let me go to the another edge flange over here, and then I'm just gonna, so as you can see, there's within the edge flange there's a one sketch, even though we didn't draw any. But when it comes to just like go to the edge flange and then just creating a sketch, so this feature itself recognizes sketch. So that's why if you're having a look at the top, there's edge flange profile. I want you to click this one, and then it's automatically turning into a kind of sketch mode. And then it's saying it's almost like under defined at the top side. That means actually the height of it is just kind of going up and down, which is not fully defined. So that's why I want you to actually just go to kind of smart dimension, and then just make sure just assign not at here. If this is possible, you can probably just assign from all the way bottom. Okay, so make sure actually the height of it is just 1.5, so when it comes to just like measuring it, it's just kind of matching all together. And then you can just assign finish, and then this is, as you can see, this feature shows no minus mark. No minus mark means fully defined. Okay, this one is actually just under defined because we didn't actually just make a dimension. So the way you can also just make a fully defined is you can also directly go to a sketch and then edit, and then you can actually just assign this value like this one to the bottom side, and then you can just assign 1.5, something like this. Yeah, that's also one other way you can do it. So yeah, there's a lot of actually ways you can just like make it fully defined, or you can even assign some equation value. And yeah, this is one another actually advanced topic, that which is the equation, how to use the equation to just manipulating those sizes just automatically. That's gonna be a little bit next step, but we are ready to go for the next step. We are not enough to just only playing with some kind of basic features. I just want you to understand how equation, how kind of smart modeling works. So for now, actually, let's just think of actually base flange and then edge flange and then close corner are definitely like, you know, one of the things that you have to just keep practicing a lot. So, and then we are gonna actually go through so for the next video, we're gonna go through some kind of flatten, and also how to export, and then how to export this kind of sheet metal for programmers, so programmer can actually just program this one and then just importing into programming. So all those kind of format, how we're gonna set this up, we're gonna go through all those manufacturing process. This is not only for the SolidWorks wise, I just want you to get familiar with the sheet metal industry, how this industry is working, so you can get some engineering understanding. So when it comes to just really working, you're not only just knowing the SolidWorks, but you're also knowing the manufacturing process. So that's gonna be double kind of helpful for you, I can promise with you. So alright, so thanks for watching video, and then if this video was helpful, please just subscribe this channel and then keep watching for the next ones, and I will see you in the next one. Bye.